For today, let's look at this interesting integration problem. We are asked to integrate 1 over 1 plus tangent to the power of 1 over 5 from 0 to pi over 2. Please give it a try before you look at the answer. This integral cannot be evaluated by usual technique of integration. We may ask, does this integrand has an antiderivative? WolframAlpha calculate the antiderivative. But it looks very complicated. So we have to find an alternative way to solve the problem. Note that this integral is from x equals to 0 to x equals pi over 2. We try to sketch the curve y equals to 1 over 1 plus tangent to the power of 1 over 5. We can get a few points easily. If we let fx equals to 1 over 1 plus tangent to the power 1 over 5, then we know that f of pi over 4 equals to 1 over 1 plus 1, which is 1 over 2. And f0 is equals to 1. And the limit of fx when x very close to pi over 2 negative, it is equals to 0. So from here, at least you get 3 points of the curve. We may try to sketch a graph as shown, but we are not sure whether this is the correct graph. Let's use GeoGebra and sketch the graph. So as shown, this is the graph of the function from 0 to pi over 2, which looks very symmetrical about the point pi over 4 half. Let us look at this problem again and ask ourselves where there is symmetry about this point. We can label the x-coordinate of any point before pi over 4 and the corresponding point after pi over 4. Is the difference of value of this y and half the same? As shown, we want to ask if a equals to b. If it does, then fx plus f of pi over 2 minus x equals 1. With this, let's consider fx plus f pi over 2 minus x. So using the definition, it is 1 over 1 plus tangent to the power 1 over 5 plus 1 over 1 plus tangent pi over 2 minus x to the power of 1 over 5. We know that tangent of pi over 2 minus x equals to cotangent x. And cotangent x equals 1 over tangent x. So the direct calculation will show that this expression indeed equals to 1 over 1 plus tangent to the power 1 over 5 plus tangent to the power of 1 over 5 over 1 plus tangent to the power of 1 over 5. And therefore the sums equals 1. Which means that f indeed symmetry about the point pi over 4 half. And since it's symmetry at this point, so we will see that the integration from 0 to pi over 2 is exactly half of the area of the rectangle with the base pi over 2 and height 1. So the answer for this is equal to pi over 4. Using the similar method, we can conclude the general result as follows. Integrate 1 over 1 plus tangent x to the power n from 0 to pi over 2 will equal to pi over 4 for any real number n. That's all for today's lesson. I'll see you again next time. Bye-bye.